So types of filter in that absorption filter, which work by the selective absorption of an unwanted wavelength, and it consists of solid sheet of a glass colored by a pigment which is dissolved or dispersed in a glass. Dye, gelatin or a similar material also used as an absorption filter. They perform as a cutoff filter and a band pass filter. So mostly the filters are such filters are used in colorimetric analysis. There are different examples: yellow, orange, red, purple, blue color. In respective absorption, bond is textless. For example, yellow 400 to 450 nanometer as like this. So each instrument provided with a 12 filter to cover the range in 319 order. So all these range are above 300 nanometer. So these are used in colorimetric analysis. So combination of filters also used in decrease the intensity of a light. Then interference filter. These are narrow band width are obtained with an interference filter, and this filter functions on the interference phenomena at a desired wavelength and permitting the rejection of unwanted radiation by the selective reflection. So again there is a selective waves wavelength containing radiations are passed in this case. So construction of interference filters, how it constructed. So it is a semi-permanent material film is deposited on a plate of a glass, semi-permanent material, and that coated with the same thin layer of the dielectric material, say magnesium fluoride. And that followed by another coating material thin layer of metal. So another plate of glass is kept on over this film for the mechanical protection. So as like this is constructed. For example, this is the plate and the semi-conducted material is there, semi-transparent material is there. Say a permanent transparent spacer film is there. Then there is wavelengths are selective wavelengths are only passed from that plate. Then interference filter, when a ray of light is incident upon an interference filter, a part of light is reflected back. Here is that part reflected back, and whereas the remaining light is transmitted. So path of the incident radiation is repeatedly by the metal layer, but at each reflection some is transmitted outward. So the several outgoing rays undergo the constructive interference. So constructive interference takes place in between that plate. For the wavelength, the beam undergoes the destructive interference and no energy is passed. So constructive and destructive interference are produced with the specific wave, means by varying the distance between the filter wave, the range can be modified. So the interference filter have the band pass from of 100 to 150 angstrom and peak transmission of 40 to 60%. So what there is the interference filter and another destructive interference, constructive and destructive interference. Those two phenomena play important role due to only the reflection of the metal is transmitted. Then comparison of energy efficiency in filter. In that case, half width, one of the phenomena is that the energy efficiency of the filter is described in terms of the width. So half width of the radiation band, so which composed to one half the maximum transmission. It is one half that maximum transmission. So the relative half width and transmission characteristic of interference absorption filter is different. So the ideal filter yields the maximum transmittance over the narrow range of the wavelength as possible is the one of the important point. So both these criteria are better meet the interference filter and absorption filter. Then interference filters are more energy efficient and yield more pure radiation, and they do not have only show the greater transmittance but also possesses the narrow half width and absorption of filter. Then monochromatomes. So these are the isolate the wavelength, usually much more than narrow filters. So essential element of monochromator is first entrance lead, dispersing element, that is prism or gratings, then exit slits, and the function of this prism or grating is to disperse the heterochromatic radiation into the component in wavelength. So it is very important point of function of the prisms and gratings. So material used for the monochromators with a suitable range, for example normal glass for visual range and cores for the ultraviolet range, and alkali halides for the infrared region. So specific material used for that specific type of spectrometer. So these are the prism having ability to interact with interact with a white light, means white light on pass on that prism, and prism separate out the different wavelength band and passes over this exit entrance slit. Then type of monochromator, dispersing element. So prism in that, and grating, replica grating. So what are the gratings? Prism already we know that, but what are the grating? Gratings cheaper than the prism, but main defect is they are provide more an order of the diffraction. So for example 400 minute for both with 800 and much interference more by the filter in front of entrance slit to absorb, so interfering radiation. So may use in a grating an element stray light, that is direct light. So construction for the grating. What are the grating? Grating are the grooves. So consist of large number of the parallel line or grooves ruled on a highly polished surface, so such as alumina, and for and that in between 15,000 to 30,000 lines per square inch are drawn on that for UV and visible region on that alumina surface, polished surface, and then light ray impinged or passed in the or bombarded on that grating. It grooves acts as a scattering centers of the light ray. So thus light is diffracted or spread out over a range of the angle and certain direction reinforcement of the constructive interference. Constructive interference may take place in this case same as that of what is happen the grooves on that grooves. Say here is a grooves on that, there is a incident light is the incident on that surface and replace and reflected in this way, and due to that grooves, so n number of the grooves are there, and that interact with that incident light and produces the reflecting light, and differently reflecting light produces the constructive interference, means produces the n number of the other waves in that case by the replicating. So replicating greater for the original grating, and this is done by the coating original grating with a film of epoxy resin which after setting removed the yield a replica, means it is the used as a mold and produces the epoxy material to produce that mold, and this replica then is made reflective by the alumina is a surface. So same phenomena is there in this case also, replicating and grating monochromata. So this is the working, that is light source of the UV radiation displaces the monochromatic light, that or a heterochromatic light in that case, or collimating mirror give the direction to on that diffraction grating monochromator, and light incident on that, and it passes by the interference, constructive interference light on that focusing mirror, and that focus towards the detector, and selectively lambda wavelength passes from the exit slit. So comparison of the prism and grating. So what will be used? So the advantage of prism is that undergo the dispersion, giving the wavelength which do not overlap but gives a non-linear dispersion. It is the disadvantage. So grating gives a linear dispersion but they overlap the spectral order. So due to this reason filters are used with the grating in the combination to sort out the first order spectrum in this case. Then what are the slits? Slits are, there are two types, entrance slit and exit slit. So function of these slits to provide a narrow source of a light so that should overlap the monochromatic light, and from this the exit slit select a narrow bands of the dispersion spectrum for the observation by the detector. So both entrance and exit slits have the equal width, so various slits also used to give the greater flexibility, and both of the slit adjust simultaneously to same width. So these will get name itself indicate that entrance slit and exit slit coming the narrow line and passing the reflected light or the unabsorbed light or the diffracted light in. So dispersion spectrum of the observed by the detector in that case. So cells means the sample cell or sample holder. So cells it is holding the sample. Usually solution should be transferred to the wavelength region being recorded. For a visible region, they are generally made of the color corrected fused glass, and thick of the cells is generally 1 centimeter. So commonly different things are taken consideration of the for colorimetry or your visible spectrophotometry, so as a sample cell, but commonly it is used 1 centimeter cell. So shape rectangular shape, cylindrical shape or cylindrical with a flat end type of the cells are used, which is made up of a cores also. So characteristics of the sample cell should be possesses transmitted characteristic at the desired wavelength and should possesses the desired path length and shapes and size. It should be impressive because that material should also follow the specifically Beer's and Lambert's law in that case. Then specifically spectroscopy required all material in the beam path than the analytical method and transfer to the radiation as possible. So the geometries of all these component of system should be in a maximum scattered light. The material which is sample cuvette is fabricated control the window that can be used. So typically material is optical glass, spatial optical glass, cords, infrared and flat. So depending upon what type of the analysis you want to do, we use specific type of the material as a sample holder respective with a 335 nanometer to so on range. Then transmission characteristic and material used for the construction of a sample cell. Already we see that different types of material used. In that case, Pyrex transmitted 300 to 20 nanometer range silica, so glass plastic also visible region. So where KBR of the material is used infrared. So depending upon the analysis, we use the specific type of the material in that case. Some identical cells where, but important is that some identical cells used for the both sample and blank solution, matched pairs should be there. So there is a instruction for use of a cell. It should be also followed for your day-to-day practical of the analysis of UV spectroscopy. So should be a constant, continuously or digitally clean and delicately clean, take into the avoid the contamination and transmitting the surface. So cleaning is very important properly, and air bubble should be removed and should not be come into that sample and prior to use. So place solvent in a cell level must be considerably above the light beam which is passing to the solution in order to avoid the reflection of the upper surface. So properly filled cell should be used for that purpose. Solvent should be solvent used in sample. So each solvent is chosen on its ability to transmit the light of the desired wavelength as well as its chemical properties. Water may be used at 180 nanometer, for example. Then important thing is the detectors, and we will see afterwards what are the detector in next video.